Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 8 in the JWT attacks module titled JWT Authentication Bypass via Algorithm Confusion with No Exposed Key. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content and then all labs, and then do a search on JWT module and go to lab number 8 titled JWT Authentication Bypass via Algorithm Confusion with No Exposed Key. Alright, let's get started. This lab uses a JWT-based mechanism for handling sessions. It uses a robust RSA key pair to sign and verify tokens. However, due to implementation flaws, this mechanism is vulnerable to algorithm confusion attacks. To solve the lab, first obtain the server's public key. Use this key to sign a modified session token that gives you access to the admin panel at /admin. Then delete the user Carlos. You can log into your own account using the following credentials, and we're giving credentials of a regular user account. Now, this is really similar to what we did in a previous lab, with the exception that we first need to obtain the server's key. And to do that, we will be using a tool called jwtforgery.py to extract that key, and then from there, we'll perform our algorithm confusion attack. All right, let's access the lab. Now, notice over here, I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. You'll see over here I've got the JWT editor extension. This is the extension that we've been using in all of our previous labs. So if you don't have it installed, go to the extensions tab and make sure to get it installed. All right, so the first thing we're going to do is go to my account and log in with the credentials that we were given. So we'll put in the username and the password, hit login. And right away, you'll see that our requests are being highlighted in green, which means that they contain a JSON web token. If you look over here, the first one is a post request to the /login endpoint. It takes in a CSRF token, a username, and a password. What the application does is when it receives this request, it takes in the username and the password. It compares them to the usernames and passwords it has in the backend. If they are valid credentials, it sets a cookie for the user in the form of a JSON web token. So if we go to the JSON web token tab, and let's make this a little bit bigger. If we go to the JSON web token tab, you could see the decoded version of the token with the payload and so on. All right, so let's go to the My Account endpoint and send this to repeater and work from repeater because it's much easier. All right, hit send, and we get a 200 OK, and we could render the My Account page of the regular user. Now let's see if there's an admin endpoint, hit send, and it looks like there is an admin endpoint, but it says the admin interface is only available if logged in as an administrator. So if we go to the JSON web token over here, you could see the subject is the regular user. Now, if we're able to change this subject to administrator and use a valid signature that is validated in the backend, then we're able to access the admin panel. To do that, we need to find some kind of implementation flaw in the way JSON web token verification is being performed. In the previous labs, we performed all these attacks. We're going to assume that we tried attacks 1 through 6 and they didn't work. And so now we're trying attack number 7. Now, in the last lab, the application was vulnerable to algorithm confusion. However, we did have the public key in order to perform this attack. In this lab over here, we're going to assume that we tried to look through all the directories in the application and we weren't able to obtain the public key. And so what we're going to do is we're going to try to extract the public key from several JSON web tokens. But before I do that, let's just refresh your memory on what algorithm confusion attacks are. So algorithm confusion, or also known as key confusion attack, is a type of attack where you force the server to verify the signature of the JSON web token using a different algorithm than the one used by the developers. Now, we have two different types of algorithms that can be used. The first one is symmetric algorithms. That's where you have only one key that is used to both sign and verify the signature of the token. And then the second one is asymmetric algorithms. That's where you have two keys. One is used to sign the token. So for signing the token, that's a private key, which is meant to be private and should not be recoverable by anyone other than the application developers. And the other one is used to verify the token, and that's the public key, which can be public, so it's not meant to really be as secret. In the previous lab, we actually were able to obtain the public key from a directory in the application. However, in this lab, we're not able to obtain it from a public directory, and so we'll need to figure out another way to extract it. But before we do that, algorithm confusion attacks usually arise when you're using asymmetric encryption, just like this one over here, RSA, and the developer doesn't properly check if the algorithm that is given in the alg parameter is actually the one that is used by the backend to sign the token. So the way the attack would work is essentially you confuse the server and get it to use a symmetric algorithm where the key that is used to sign and verify the token is the public key. And that's why we're trying to obtain the public key. Now, in the previous lab, the public key was available to us to download in a directory on the server. In this lab, it's not, and so we will be using a tool to try and derive the public key from two signed JSON Web Tokens that were signed with the corresponding private key. Now, it's not possible to derive the private key from a JSON Web Token because it's meant to be private. However, in certain cases, it is possible to derive a public key because it's not meant to be a secret, it's not meant to be private. I don't know the exact math of it, but I believe in order for this attack to work, the padding used by the algorithm needs to be deterministic, and the public exponent needs to be known or can be brute forced easily. If that doesn't make any sense to you, that's completely okay. There's already a tool that is built for you that does all this legwork, and so you don't really need to understand the math behind this. But the idea over here is if you have multiple JSON Web Tokens, you may be able to extract the public key, and then if the application is vulnerable to algorithm confusion, then you could exploit this vulnerability using the public key that you extracted in order to gain access to the admin account. Now, the vulnerability over here is not the fact that you could extract the public key. This one is meant to be public. The vulnerability over here is that it's vulnerable to algorithm confusion. All right, let's look at the tool that Portswigger mentioned. It's called jotforgery.py. So we're going to right click this and open this in a new tab. And it looks like they created some kind of simplified version of the tool, which we could run in a single command. What I'm going to do is I'm just going to use the original tool from over here. So let's go to the GitHub repo. And this is the tool that we're going to use. We need to clone the library. So let's copy the link. Open CMD. And let's make this a little bit bigger so that you guys could see it. Okay, this should be good enough. What we're going to do is we're going to go into desktop, and then we'll say git clone, and then we'll add the link to the repository and hit enter. Now I've already cloned this repository, and so it won't allow me to clone it again. But essentially, if this is the first time that you're cloning it, it will take a couple of seconds to download the library. And if you don't have Git installed, you could install it using apt-get install. All right, so let's go into this directory over here. So cd rsa sign to n and view the content of the directory. You could see there's a standalone directory. We're going to enter that because that is the recommended way of running the tool. Let's clear our terminal and then say ls to output the content of the directory, and right away you see that there's a readme.md file, which will give us instructions on how to run this tool. So let's output the content of readme.md. And it tells you need to first build the tool, and then you need to run it, and then in the container you could run the Python script, and it takes in two parameters. The first one is a JSON Web Token, and the second one is another JSON Web Token, because for this attack to work, you need at least two different JSON Web Tokens to try and determine what the public key is. So that's what we're going to do. Let's say docker build .-t sign to 1. Again, I've run this before, and so you'll see it only takes a second for me because it's already built. For you, when you actually run this, it might take a couple of minutes for it to run. And then the next thing we're going to do is we're going to run our container. So copy selection, paste it in here. And here we go, we're in. Now we just need to run the Python script. Let's copy that, paste it in here, and that ran it on the incorrect JSON Web Token. So let me see if I could clear, and I can. And here we go. So over here, we need to add our JSON Web Tokens. Let's go back to the lab. I hope it's still running. And it is. All right, perfect. So we already have one JSON Web Token when we logged in. So let's copy that one. And go back to our terminal. We'll add it over here. And then we need another JSON Web Token for this attack to potentially work. Again, it might not work. It really depends on the padding scheme and the exponent that was used in the algorithm. So let's log out and log in one more time. And then get that JSON Web Token from proxy. Let's copy it. And go to terminal and paste it on over here. Here we go. So now we have two JSON Web Tokens. Hit enter. And so what the script is going to do is it's going to try and determine what the public key is. It might identify multiple public keys. Only one of them is going to work because this is essentially a very educated guessing game. So what we're going to do is if it determines multiple public keys, we're going to determine which one is the correct one by seeing which JSON Web Token works. And then based on that, we'll use that public key in order to generate our new token. So again, this might take a couple of minutes to run. It really depends on how many tries it needs to make. And here we go. It output it. Let's see how many public keys. So it looks like we got only 2. So that's good. We only have to try 2. So what this did is essentially it calculated 2 potential public keys over here, and then it outputted a tempered jot that is signed with these public keys. Now, if we're able to access the regular user's account using one of these tempered jots, that means that's the public key that is used by the application, and that the application is vulnerable to algorithm confusion. So before I change this, actually let's send this to repeater just in case we need it again. Okay, before I change this, if we go to JSON Web Token, this is using asymmetric encryption. Now, when I do change it to the tempered token, which is signed with the public key, you'll see now it's using symmetric encryption because it's trying to exploit algorithm confusion by using the public key to sign the token. So let's hit send. If we get a 200 OK, that means this is the correct public key and it's vulnerable to algorithm confusion. We get a 401, so that's not a good sign. Let's try the second one. Let's copy it properly. And paste it in here. Hit send. And we also get a 401 unauthorized. Oh, And that's because we're actually trying to access the admin panel, and this is the regular user account. So I'm actually trying to only access the regular user accounts page. So let's send this to repeater. That's why both of them did not work. One of them should work if the tool outputted those public keys. So let's copy the JWT, paste it in here. Now this is a JSON Web Token for the regular user. If it truly is vulnerable to algorithm confusion, then we should be able to access the page over here, and we can't. We access the login page, so this one's not right. Let's try this one. Paste it in here. Hit send, and we get a 200 OK, which means that the application is vulnerable to algorithm confusion, and we were able to identify the public key. So the public key is the one for this JSON Web Token, which is the first one over here. It was written to this file over here. So if you look over here, it's still the same exact JSON Web Token for the regular user. The only difference is now it's using the symmetric encryption algorithm, and it signed the token using that public key that we're going to output right now. Okay, so we finished step number 1 of the attack. We identified the public key. This was given to us in the previous lab, but because in this lab it wasn't given to us, we had to actually extract it. So let's output the public key that did work. So it was this one over here. Paste it in here, and then copy the entire thing. Now we need to change our JSON Web Token to access the administrator account and then sign our token using this public key over here. So we're going to go to our JWT editor tab, and let's delete any keys that we already have so that we don't get confused. Click on new symmetric key, and then click generate over here, and we're going to replace K with a base64 encoded version of our public key. So we actually need to base64 encode it first. So go to the decoder tab, put it in here. I believe there should be a space after. Encode as base64, and then copy this entire thing over here. Go to JWT editor, again, new symmetric key, generate, and in the K parameter over here, add our base64 encoded public key. Click OK. Go back to repeater, to the request where we wanted to access the admin panel. However, we're not allowed to because our JSON Web Token does not fit for the administrator. So let's change this to, actually let's do it on the second one because this one already has the correct algorithm on it. So we'll change this to administrator. And now we need to sign our token using the public key. So sign. And this is the key that we just generated. Click OK. And hopefully this works. Hit send. And it still says 401 unauthorized. So we spelled this correctly. This is symmetric algorithm. And my guess is that I copied this incorrectly. So if you copy this incorrectly, it's not going to work. Let's copy this and just decode it again. Sorry, encode it again. And I'm going to say encode as base64. Copy it. Go back to JWT editor. We'll delete this one. Say yes. New symmetric key. Generate. Change it over here. Click OK. Go back to repeater. This is administrator, and this looks good. Let's sign it with the key that we just generated. Click OK, go back to raw and hit send. And it's still a 401 unauthorized, which does not make sense. So if we go back, The one that worked is this one, which was written to this file over here. And that's not the file that we outputted. This is why it's not working. We outputted the incorrect file. So this is the one that we outputted, which is for the JSON Web Token that did not work. So let's copy this and output it. This is why we actually check the JSON Web Tokens first to confirm which public key works. So let's copy that. Go to decoder, paste it in here, encode as base64, copy the entire thing, go back to JWT editor. Let's delete this one so that we don't get confused by it. New symmetric key, generate, and hopefully this is gonna work. So this is our correct public key. Click OK, go back to repeater, go to JSON Web Token. We already changed our payload, so now all we need to do is sign it with our new key. Hit send, and we get a 200 OK. All right, so previously we used the incorrect key by accident, but now we're using the correct one, so we are able to access the admin panel. So this confirms that the application is vulnerable to algorithm confusion, and we were able to extract the correct public key. Now, in order to complete the lab, we do need to delete the Carlos user. So let's see the path to delete the Carlos user. Let's copy that. Go to raw and delete it from here. Hit send. And we get a 302, which means that it did delete the user. And if we render over here, you could see the user is no longer there. And we get a congratulations, you solved the lab. All right, so we successfully completed this exercise by first extracting the public key from 2 JSON Web Tokens and then using that public key in order to perform an algorithm confusion attack to access the admin panel.